There is this artist that I admire. More than 3 years ago, he created a small animation out of 24 frames, all painted in different styles. Just like a song gets stuck in your brain, for some reason this animation got stuck in mine. Till today, I can still go back to just admire this unique and cool animation. By watching it again the other day, it gave me an idea. What if I could give this piece of art a second life? A new medium? What if I can make the animation physical? Let me explain. There is this concept called Automata. These are mechanical sculptures. Through simple movements like a basic rotation, can create what we might call physical animations. In the past, I've designed various automata, including a giraffe, an astronaut, and a biker. And now I'm gonna try to create this animation into a physical automata. From one single circular motion, converting it into this character skateboarding on a skateboard. So let's see how it goes. First, I had to get a feel for how the character moves. I simplified the original animation by sketching just the character's outlines. I divided the character down into different body parts to figure out where the joints could go and where to add movement. The head and the upper body could be one piece, with the arms and the hands as another, and the legs and the feet as a separate section. I aimed to keep the movement as simple as possible. To do so, I experimented with animating the character between two distinct stages to see if that would be enough to create a smooth and trustworthy motion. After a few tweaks, the motion started to look just right. With the basic motion set, my next step was to figure out how one movement, starting from the right foot, could trigger another movement. Basically, I need to figure out how this foot, moving in a circle, make the upper body bounce back and forth and get the arms to swing in opposite directions. I realized that I couldn't solve this problem just by looking at it in 2D. So I went ahead and cut the character out of a piece of cardboard to better understand its movement, and pressed a toothpick through the joints. This way, I realized that the left foot could be the static point. The leg could stay still with a hole in it, allowing the other parts to rotate around it. Additionally, splitting the left leg into two parts allowed for more free motion. Looking at the animation again, I noticed two important distinctions. When the upper body was tilted forward, the leg swung back, and when the upper body straightened out, the leg was swung forward. This meant I couldn't just attach them directly to each other, as that could cause the upper body to tilt too far backward. After some pondering, I came up with the idea to cut out a small hole that followed the radius of the circle and extrude a small part of the leg to track this path. This way, the motion was constrained when the leg was pushed backwards, but allowed for free movement when pushed in the opposite direction. I exported the 2D shapes as editable SVG files and then imported them into the 3D software. I turned the 2D files into 3D by extruding the surfaces. After assembling all the 3D components, it became clear that stacking all the body parts on top of each other would make the design too bulky. So I redesigned it by integrating the legs into the body while keeping the arms separate. It was time to get a physical sense of the movement and see if it looked good in real life. I tried moving the legs and the body, and it was a cool experience. It felt like it had come to life. The movement needed a few tweaks, of course, such as a smaller hole inside to minimize the body's movement. One thing that really annoyed me was that every time I left the desk, for just a moment, something weird would happen. When I came back, the skater guy was always on the floor in pieces. It became clear that the assembly needed glue to stay together, which I wanted to avoid in the final version. I'd prefer if it fit together by simply snapping the parts into place. Now I'm at the tricky part, figuring out how one rotation can move the leg in the way I wanted. In a 2D motion simulation program, I reused the mechanism from my previous giraffe project and added 2 more links to act as the upper and the lower leg. I moved the leg into the desired positions in both the real world and in the 3D model. Then I took some photos and compared them with the links in the simulation program. I fine-tuned the length of the different links until the motion path looked just right. I couldn't get the exact movement I wanted, but it was close enough. Once the exact dimensions were set, I took a screenshot and placed it into the 3D software. Inside the 3D software, I created 3D links for all these components and added a gear to the rotation. However, when I tried rotating the gear, I had to turn it counterclockwise, and it ended up being off-center, and that is not what I wanted. With a few adjustments, I added a second gear to shift the motion to the center and reverse the direction. I expanded the box, made holes for the gears and links, and added soft edges. I also adjusted the dimensions so the whole thing could snap together seamlessly. I added a knob to the rotational point with the same design as for my last project. I tested the whole thing digitally, and it looked good. It actually seemed to work. So it was time to print. And then I began assembling it. It actually came together pretty easily, no major complications this time, which is rare. Everything clicked together just like I wanted. Testing it for the first time, I realized the leg movement was fine, but the upper body tipped too far due to the weight of the head, something that didn't show up in the 3D model. Unfortunately, real-world physics had won over the design. The arms also moved a bit too much. Back in the software, I extended the edges of the upper body to limit the motion and thicken the arm joints. And now it worked. The final piece was printed in white, and it was done. This project felt great because it didn't require a lot of quick fixes with glue. Most parts came together by snapping them into place, which allowed me to easily remove and replace parts as needed. If I were to redo it again, I'd print the figure in white so it could be painted afterwards in different styles, just like the animation. But since I was out of white material, it turned out pretty cool as a silhouette instead. If you made it this far, thank you for taking the time. I hope you enjoyed this project, and if you liked it, I think you'll enjoy the giraffe project as well. I had a great time working on that one too.